All right, we're picking up on problem 57. You should have typed in your answer already for this, but go ahead and check it. Make sure your equation is correct. We're going to start with t of n equals. Our common difference is it's growing by 3 in this pattern, and the starting value is what comes before the negative 4. If I go backwards, instead of adding 3, I'm going to subtract 3 from negative 4, and that's how I'm at negative 7. Okay, so that's our starting value, and this 3 was our common difference. So verify your equation works for each of the first 4 terms. So we're just plugging in the order that the number is in the list, right? This is the first, second, third, fourth number in the list. We're plugging those numbers I just wrote down in for our n in our equation. And did I get the value from my list of numbers? Yep, when I plugged in a 1, the first number, it gave me a negative 4, which is what I wanted it to show, okay? So is it possible for t of n, which is your equation, to equal 42? So I'm going to set that equal to my 42 equal to the equation. Okay, I just replaced t of n with the 42 number, and now I'm going to solve. So if I add 7 to both sides, I get 3n equals 49. If I do 49 divided by 3, all right, let me rewrite that up here. 3n equals 49 divided by 3. I get n equals about 16.3 repeating. Okay. So what does this tell us? And is it possible for our equation for our sequence to equal 42? Remember, these n's tell us, maybe we'll write that over here. N's are the order number in the list. Okay, the number that the term is in the list. So if n was worth 1, that means that was the first number here, which was, in our case, was worth negative 4. So if I solve this and get n equals 16.3 repeating, that means it's the 16.3 term in my list. Okay, that would be the 16.3 term. Can I have that type of term in the list? Can I jump in between the 16th and the 17th term and have something in between there? That's not possible. So is it possible? No, because it must be a whole number in the list. Okay, this tells me the order it is in the list. So since there's no 16.3 repeating term, it doesn't exist. So this is not able to equal 42, even though we solved it and got an answer. So part D says for the function f of x equals 3x minus 7, is it possible for that to equal 42? And explain. So first of all, what's the difference between these two questions? Is the letters they're using, okay? F of x, and then they're using an x. We used t of n and n. So we're going to talk about the difference in this problem down here. So if I solve this, set my equation equal to 42 again, I'll add 7, and I'll still divide by 3. So I still get the same answer, 16.3 repeating. But is it possible for it to equal that? Let's jump down to E and see what we can decide and see if that helps for D. Explain the difference between these two. Okay? So t of n is talking about a sequence, which is a list of numbers. It's also talking about points only. Right? We said on the front it was discrete, which means you do not connect the points. So only positive, only positive, I called them natural numbers up there. We'll say whole numbers, even though that includes 0. Starting from like 1, 2, 3, 4, only those numbers are able to work for the domain. Okay, remember, domain means x, or in this case n, because we're using the different letter. Okay? And if it says f of x, now we're talking about a line that the points are connected. So I could have things in between the points, right? If I connected the lines, I'm assuming I have all those spaces in between will work. So that means I can have decimals are okay. Decimals are okay for our domain or for our n value or our x value. So back to D, is it possible for this f of x to equal 42? Since we're talking about a line that has connected points, I can have decimals. I have a value that will plot on my graph at 16.3 repeating. The difference is the t of n is talking about the sequence, so you can't have anything in between the first number and the second number, or the second number and the third number. So no decimals are allowed with my t of n, but this one, yes, let's write it over here, maybe yes, is explained. It is the line has connected points, so decimals included. Okay, if I have a decimal in between there, I'm going to assume that I can connect everything in between. All but those numbers in between my points would be values that work. All right, so hopefully that makes sense there, and go back to the Google forum page and make sure you're answering the questions on there as you continue.